Okay, so this is going to be exponential functions number 2. And on your device, open up a tab and go to Desmos quickly. Go to desmos.com. desmos.com. Go there quickly, open up a tab, and thank you for those of you that were closing them so you can concentrate on this. Okay, are you going? Go to the tab, go quickly. You're going to do 3. The ones on the board, and put them into different little boxes. Yeah, say f of x equals, perfect. Say f of x equals. What kind of notation are we using here? What's the name of this notation? Blank notation. Do you know the f of x as opposed to y? So we could have said y equaled this, right? Because it's got a y and an x in it. Or we can use f of x. This is the function notation. Function notation is the f of x. These parentheses are pronounced f of x as you go. Okay, are you typing them in? So do you have multiple ones in there? Do you see what's happening to the curve? What do we say about this curve? What's happening to it? What kind of curve is this? So remember when we had the quadratic we graphed, we got what kind of graph? A parabola, good. Now you're into a different type of graph with this. What's the name of the graph? Everybody say exponential. Okay, everybody say exponential. All right, so what's happening in exponential? This is your typical, might as well think of it as the COVID virus graph, right? Because it's so relevant to you. When I was in school, we had the flu that we would talk about, but we didn't have COVID-19, right? Where you guys have now lived through the exponential curve. You've witnessed it happen globally, and it's repeating itself. Even now, every time they talk about an outbreak, cases are increasing, something's happening along this line, right? Here's the graph, there's people sick, and all of a sudden, everybody's sick, right? And there's this weird thing back here where you don't even know it exists. Look how flat that curve is, right? We don't know that anybody's even sick here. Here, we're starting to go, whoa, what's happening? And here, we're like out of control. Everybody's sick, right? What is it that stops everybody from dying on Earth? How come we don't just all die off? Which we may someday. But so far we haven't, knock on wood, right? From at least the current present time, through history, there have been some pretty bad events like this, right? Why don't we all die off? Well, we try to flatten the curve. You heard about that. So we all stay away from each other, right? So we don't spread it as fast. We do 6 feet of space between us. We wear masks. We do different things. We get vaccinations, right? Different strategies to stop this curve from exploding. Where's the power in this thing? The power is the variable. That's what makes it exponential. The power is the variable. So you're used to things like x squared, right? The 2 is the power. Now all of a sudden it's reversing. You've got a 2 to the x power. And that's when you did the caret or you did the little a to the b power in Desmos. That's what's making that happen. Where is it crossing the graph right here? Can you see where it's crossing the y-axis? What number is it crossing at? Right here. Can you look at your graphs and see? Where is it crossing the y-axis right there? You able to zoom in a little bit closer? Yeah, can you see, Melanie? Are you able to see a number right by there? 2 on this one? Is this one going at 2? Is that this one? Going at 2? And then I want you to look at each one. See where it crosses. All of them are behaving exponentially, right? That's what it does with the variable up in the power position. Where's the second one? Yeah, right here. Zoom in here. Can you zoom in on that intersection right there? Yeah. So one of them is at 0.5. So this one, correct me if I'm wrong, this one's at 1/2 right. Okay. This one's at 1/2 right here, right? 0.5. Does that make sense? Do you see it? And notice what this term is right here. Where's this one crossing? The one with the negative. That one's going negative this way, right? What's this number here? Can you zoom in on that one? -1. Good. Do you see that that would make sense, because what's the coefficient right in front of this parentheses? What's that got to be? It's got to be a 1 there, right? Okay, predict where this one's going to cross the y-axis. Can you predict? Where's this one going to cross the y-axis? And then look it up and check it. You see the pattern emerging? You see it, Natalie? Are you able to zoom in on it? Does it make sense? Can you see it there? Zooming in. Yeah, right there. Go closer. Double tap. Go more. And so see, look, this is 1. And how far up are we here? Do you see that? Does that make sense in terms of this right here? You see that coming out there? They're giving you decimal. They're giving you 0.333, right? That's what's determining that. So if you had a graph, could you then go back and build what the function is? Right? If we have a graph crossing at a certain place, can you then know what that's going to happen? And then do you see if you vary, maybe go back and I want you to vary these numbers here. Vary this term and this term here and see what happens. What we should see is an increase in steepness, right? Either steepness up, if it's positive, should go even steeper for a larger number. And as we're going down, should be steepness down if this is a larger number. Look at your 4, your -4. And see how that goes. It's a little bit hard to tell, but it's not going down as fast as these are going up. Look at how close these are coming straight up there. Okay, so this should be enough to get you going on the Schoology assignment. They're going to give you different either functions or graphs, and then ask you different aspects about it. Use Desmos to help yourself through it. Just type them into Desmos if you need to look at what it is, and then just turn them on and off like you have on your screen right now. Okay. Anything else in this one's pretty short, and this is sort of Algebra 2 light to prep you for a lot of stuff you're going to do next year. All right, that's good.